over lunch. Now the debate starts today. Tuesday, October 19th, after school.
Okay, I don't care how you get there, just get there.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'm so happy my birthday was last Sunday. I don't celebrate my birthday.
What? My birthday's like my favorite day. My favorite day.
I sat at home.
Mine texts me. Actually, I like Christmas.
Gifts make me incredibly uncomfortable, so I hide that knowledge from everyone.
Who texted you about that thing?
About what you want.
No, about birthdays. Come on, Meow, do the thing. I'll tell you that it is factorable, but if you want to do the what do I feel lucky about business, that's fine. Just remember to take it all the way to linear factors. A linear factor is x minus c.
I didn't get to watch the live stream yesterday.
Okay?
Do I need to have the live stream take place? I'm assuming yes.
Do you need to know what we did yesterday to do the daily quiz about yesterday?
That's fair enough. I take it later.
Don't do it now. Wander down during Spartan time tomorrow. I'll give you a different one.
Sounds good. Thank you.
Bless you.
Okay, we're kind of wrapping up the meat and potatoes of Algebra 2 and extending it right now. Hopefully finish rational functions today. Hopefully we can knock out all of 2.6 tomorrow, and then we'll jump in chapter 3. 3 should be fast. It is review of exponentials and logs. Not much different between that and Algebra 2, so it should be fast. After that, then we're in all new territory. We'll spend about 3-4 weeks in chapter 4, which is trig functions. Like the I need to know this before going across the hall next semester stuff. But got to get through this first. Also, there was, let's say about half of you didn't turn in a notebook or anything. So I ain't gonna get to it today. But if you want to turn those in again after class tomorrow so I can go through them tomorrow, block 2, I would like to put that stuff in. I started on quiz 5, grading those. Got all of Algebra 2 knocked out. So we're doing a little bit better this time around. Your next quiz will be next week, and quiz 6 will be the end of quarter 1. I know it feels like we just did midterm like a week ago, but nah. End of quarter 1 is 29th, next Friday. Yep. So that'll go through quiz 6. So whatever you got right now, plus 2 more quizzes. Anyone still rolling? I see a couple scratching away. I'm going to do this 2 ways, because I did see kids doing it both ways. Option 1, factoring. If you can identify quadratic form in there, and if Frank isn't a cross-eyed Florida man, you know how many disgusting headlines begin with a Florida man?
A lot. Every single one I used in Spears class.
You know you have someone from Florida in your room like every day at lunch.
Yep. Well, we have a couple of Floridians in Game Club, and they're absolutely bonkers. So, I get that. 3x to the 4th plus 10x squared minus 8. That is quadratic form right there. Whatever my middle term is half the degree of the leading term and then a constant. So I'm just separating that out. Because if I do, then I can factor each part. This factors just like any quadratic. I'm not going to do full AC method on it because I know that the only way to make 3x to the 4th is 3x squared by x squared. 3 is prime. I just need to kind of guess and check a few factors of -8 to see what makes 10 in the middle, and that's plus 4 minus 2. Over here, I'll take out a 5x, leaving a x squared plus 4. If I take x squared plus 4 out, leaves me with 3x squared minus 5x minus 2. Why am I hearing things? God damn. All right. So it's perfectly fine to talk to yourself unless yourself talks back.
That's what my boss says when I work in Vegas.
So what's yourself talking back?
Okay.
Said as long as you don't talk back to yourself, then you're not crazy. So you can talk to yourself.
You can talk to yourself, but as soon as you start hearing a response, that's when you're in trouble.
Yeah.
Yes.
Because
Okay.
you can catch me talking to myself.
Oh, you're supposed to.
Yeah.
Like, we actually were talking about this in our Brain Games channel and on our Game Club Discord the other day, where you are supposed to, as a human being, verbalize what you are thinking. We are meant to talk to ourselves. But, you know, demons and possession and Christian puritanical values and ingrained in our culture for 200 years, now we think that we can't do that because you're crazy. No, I'm just talking to myself. I am verbalizing what is in my head. But Psychology and sociology are amazing things. Okay, so yellow line is where I can get by factoring. That is called product of linear and irreducible quadratic factors. I'm supposed to go all the way to linear factors, so I have to go to the orange part. When I have the sum of squares, I think we're okay with this now. Difference of squares would be x plus 2, x minus 2. So by having sum of squares, the only difference is there's going to be i's there. So I can do this entirely by factoring. Or what I saw, I'd say probably 3/4 or more of you doing, was synthetic until I hit the quadratic. Running with, what, 2, and what's next? 1/3, negative. 0, 0, 12, -4, 0. And then cut that line out and call it 1, 0, 4. If you do that, you now have x squared plus 4, and you have to be able to, I don't know, maybe do x squared is -4, so x is plus or minus 2i. So it doesn't matter which route you take, right? You can do synthetic to find the zeros. If you find the zeros, then you can write the linear factorization of it. What I want to be careful about, I wrote mine like this. If you had instead written this part as x plus 1/3, and then x minus 2i, x plus 2i. What's different? It's still the same zero. Okay, the difference between 3x plus 1 and x plus 1/3 is in the amplitude of the function. One of these functions is 3 times taller than the other. So if you do this, you have to remember that there's a 3 out front. Okay? Where you distribute that 3 in is entirely your choice, but we know it goes to the x plus 1/3. So I will take either one of these. Both of those are correct. If you, however, wrote the x plus 1/3 and you do not have a 3 out front, we're going to have to take one off because you don't have the full function. You have most of it. So, because this one involved a lot of steps and you could have taken different routes, here's what we're going to do. We're going to go Likert on this. Okay, this is where you were supposed to get. The Likert scale is a rating. You got all the way to the linear factorization. You got the work to back it up. Good job. You came close. Like, you missed the 3. Or maybe you said x plus 2, x minus 2, you forgot the i's that go with them. But you did have x squared plus 4 right above it. Okay. I made a pretty big goof. Like, I was definitely headed down the right trail, but I screwed up something significant. I have factors, I have some of those factors, but I definitely screwed up. Well, that sucked. I'm not even in the right ballpark, but at least I tried to factor. I tried, or I did synthetic, and I got lost in the sauce over here, okay? I attempted the problem. You didn't even attempt the problem. Okay? A Likert scale is a scale rating. You see these all the time when you have to do like a survey that says I strongly disagree to I strongly agree. Okay?
Like they do to us all the time during advisory.
And a good survey of that kind will always remove the neutral because it's statistically proven that people will just choose neutral if they have that as an option. Okay? Like, no, you got a feeling about this one way or another. It's just how strong it is. So choose. Kind of like on day one when Anna refused to tell me her name and said, whatever. Okay. So you have a feeling about the thing. In this case, Likert Scale says, how well did you do? You know how well you did. Okay? So something out of 5. Any questions about it? I cans. You go away. You go away. There we go. Sheep. Okay. So there is a part of factoring that our book does not explicitly go through, and they expect that you just remember this. I would write this down in your notes somewhere in section 2.2 or 2.4, probably 2.4, since that's where we spent a lot of the time. If I ever have a cubed plus b cubed, the special factorization for it is a plus b times a squared minus ab plus b squared. If I ever have a cubed minus b cubed, its special factor form is a minus b, a squared plus ab plus b squared. So it's just, it changes up the signs, kind of like our quadratic cheater for complex and compound roots. So the reason that this gets really goofy, and I wanted to see if we remembered it or not. I can find the real root for this, no problem. Right? If I just said x cubed plus 16 is 0. The catch is 16, negative 16, isn't a perfect cube. So you'd have to say the cube root of negative 16, if we remember how radicals work. Negative 16 can be written as negative 1 by 2 cubed is 8 by another 2. It's negative 2 cube root of 2. Blech. Okay, so that's the one real root. The others are going to be imaginary. And writing this out in this form is going to be disgusting. Because I have to now write what cubed makes x cubed. Well, x. But b, cube root of 16, which is 2 cube root of 2. Or if you just, well, that's the 0. Like if I'm just plugging it in here, it's going to be. Or if I just say cube root of 16, I know that's not simplified, but maybe I'll use that for now. I have to plug x and cube root of 16, or 2 cube root of 2, into this formula. Yeah. The 0 is negative 2 cube root of 2. The b value is positive. So a plus b, x plus 2 cube root of 2. You see where that'll get the negative 2 cube root of 2 as the 0? Like if I just set an equal to 0 and subtract. X squared minus a times b. 2 cube root of 2x. Plus b squared. Okay, 16 to the 2/3. How about, what's 16 squared?
Oh. Are we supposed to know that?
Yeah. Perfect squares through 20. Is that a perfect cube? Can I do the cube root of 256?
Oh my gosh.
Okay, because this is 2 to the 4th. Right? 16 is 2 to the 4th. And if I square that, whether I apply it in here or in here, it's the same difference. It's cube root of 2 to the 8th. So I can take 2 to the 6, 2 squared.
Did you think we were supposed to get this?
I expected that you were going to leave it as cube root of 16 because you don't have enough experience with radicals, because our geometry and at least half of our algebra 2 don't force you to work with radicals. But 4 cube root of 4 is that squared. No, I didn't expect anyone to get it 100% on their own. I expected someone to ask so we could talk about it. Yeah, I put like one like that in every assignment. So when I say, are there any questions? And then it was like, nah, we're good. I know you're full of it. Okay, I just want you to ask. I want to have a discussion about this. If this hadn't been 16, if that had just been 8, you should have been able to do it because you did it in algebra 2. What cube makes 8? Okay, cool. X plus 2, x squared minus 2x plus 4. Ta-da! There you go. That's your answer. You did that in algebra 2. I picked this one because we should know how to work with radicals. We should know how to work with the cube root of 16, even if it's butt ugly. That was the only difference, is a perfect cube versus not a perfect cube. Everything that you worked with in algebra 2 had that as a perfect cube number. What happens when it's not? Okay. It's also why I go on all these mathematical tangents here, is because I want you to at least see it. I want you to think about, well, what if that? You don't understand how much of the stuff in your textbooks, your problem sets, your quizzes, the examples in the notes, they're all numbers that are made to work. because we reverse engineer the problems. Most of your problems for your quizzes, I reverse engineer them to make sure that they'll come out decent. What if it doesn't? Yeah.
So for like 70 and 71, you have a cube and then a square. So is that?
You have to deal with ugly.
So are they just? Is it just 9 and a root?
Yeah, cube root of 9.
Okay.
That's it. You just work with that. Where this one got nasty is because it could simplify to a 2 cube root of 2. But if you don't have those yellow formulas, the sum and difference of cubes written down, if you don't remember those from Algebra 2, it's just kind of expected from this point forward that if you ever run across sum or difference of cubes, you can do that. Okay? That's why we have that prereq to get into PreCalc. That's why you have to have at minimum a C in PreCalc to move on to trig. Like, we have these requirements because if you're not at least that level, you're just boned. Okay? Like, it's no good. All right. That was the thing. That was the thing. Now you can go away. There we go. We left off with asymptotes. That whole guess and check thing about where the asymptote is. How many of you, like, say 1A, which, by the way, is an amazing NPR segment, 1A. Like, follow them online. They're great. How many of you had to change the window? Well, now all of my little tick marks on my graph are too close together, and I can't tell if it's actually 15 or is it 14, and you had to guess and check some numbers to make sure that it worked. Okay? What if I told you that there's a trick to it that was super easy? I want you to look at the horizontal asymptotes for all of these. Look at those 3. Look at what the horizontal asymptotes were. 1, 2, and 15. Table flip! Okay? Because there's special rules. Boy, that was a real narrowing of the eyes right there. Like, if there's anyone in this room I would actually be afraid of, it'd be you too. So, okay. Not for 1B. What's different between those to B? Okay, there's a quadratic. Well, no, B had quadratics. They're not the same degree. And that's what gets us into, there are rules that determine what your horizontal or oblique asymptotes were. Remember, this one had an asymptote like, hold on, -4, -5, and -5. Okay, in fact, if you haven't cleared out your calculator, that was the last one we did, you should still have this in your calculator if you got the same one. Like, an oblique asymptote is one that is diagonal. Specifically, this one's going to be linear because the numerator is 1 degree larger than the denominator. Linear, x to the first. So it's entirely possible if that numerator is 2 degrees larger than your numerator or your denominator, you can have a parabolic asymptote. You can have a graph like this. Now that's calculus. We're not going to go past linear. Okay? But it's a thing. Yes, sir.
So are like the asymptotes just basically where The line doesn't go.
The invisible line that you cannot cross, except for the very special cases when you can cross it.
It's basically just the limit, writing the limit, but like
Let's do some first. All right.
I know. Like, we write the limit.
So we're going to come back to these. Instead, I want to just talk about the rules. Now, that's a lot of mathese. Most kids are just going to see this and not even attempt to start reading the lines. A rational function. Rational means fractions. Given by this. We've talked about this before. These are in sequence notation. They write it like this because it covers every possible polynomial. If I have a degree n, this is the coefficient that goes with the nth term. This is the coefficient that goes with the term after that. So if like this is 20, then this is x to the 19th. So this is the coefficient that goes with x to the 19th. All the way down to a sub 2, x squared. A sub 1, x to the first. A sub 0, x to the 0, constant. So this is just sequence notation to write out every polynomial, whatever n is. Okay? So if I have polynomial over polynomial, whatever they may be, b of x does not equal 0. Why do they say that? Can't divide by 0. Okay? Pick it apart. This isn't just math on paper. Like, no, there's meaning here. A of x and b of x have no common factors other than 1. Why would I not want that and that to have common factors? What would happen? Holes, right? Removable discontinuity when I cross them out. Then the graph has these characteristics. Vertical asymptotes occur at the zeros of b of x. You might want to write that down. The zeros are the vertical asymptotes. So if I set the denominator equal to 0, I get my vertical asymptotes. I'm going to go even further. Oh, no, they wrote it here. Good job. So I'm going to kind of skip this stuff right now, come down to intercepts. The x-intercepts, if any, occur at the zeros of a of x. So I'll write that down and say the zeros of the numerator get me my x-intercepts. How do I find y-intercepts? Like in any function. X equals 0. The y-intercept, if it exists, is the value of f when x equals 0. So maybe just next to this, I'll say f of 0 is y-intercept. I'll just remind myself of that. So we're starting to build a graph out of this already. If I look at the zeros of the denominator, I get my vertical asymptotes. Zeros of the numerator, I got x-intercepts. Plug in a 0, I get a y-intercept. We're starting to build features of the graph. This is the part that's new to us. They're going to write this as a sub n x sub n, or x to the n. B sub m x. Okay? So if I have this, just this part, only looking at leading terms, if n is greater than m, your horizontal asymptote is 0. Meaning if the numerator is a smaller degree than the denominator, y equals 0. That's it. That's where your horizontal asymptote will be. If they're equal, which is what we saw on that last page, then it's the leading coefficients. That's why we ended up with 1 over 1, 8 over 4, 15 over 1. Because all of them had equal degrees, numerator and denominator. So they all followed this rule. If the degree on the top is greater than m, there isn't a horizontal asymptote. There will be an oblique. And however many degrees bigger it is, that's what the shape of that asymptote is. If it's 1 greater, you're going to have a line. If it's 2 greater, it's going to be a parabola. If it's 3 greater, it's going to be a cubic asymptote. But again, go to calc. Do all that there. Okay. So what I want you to put next to this one, because they don't specifically say it, is if n is greater than m, there is no horizontal asymptote. There is instead an oblique. And all you have to do is divide and ignore the remainder. And you do want to ignore the remainder because there will be one. There has to be one. Because if there wasn't a remainder, that means it's a factor. If it's a factor, then I would have broken that very first line and they would have been factors of one another. I would have been able to cancel something and have a whole. Okay. Now, we will have rational graphs that have a hole in them later, but it's important to write that you divide and ignore the remainder because there will be one. It's rules, okay? It's just rules that you follow to make the graph. Kind of like when we were just doing the polynomials and I said the multiplicity of the zeros determines its behavior at those zeros. These are just a new set of rules, but these work for rationals instead of polynomials. So, see it in action. Determine vertical and horizontal asymptotes, intercepts, graph the function, Satan's domain. So, step 1. Find the zeros of the denominator. -3. Those tell me my vertical asymptotes. So I'll say there's a vertical asymptote at x equals -3.
Well, that sounds like something when you do a dotted line. Not like
You
a
said
vehicle,
X.
but like what's it called? It's something animated.
And I will find zeros of the numerator to get x-intercepts. Set the numerator equal to 0. 6 equals 0. That's not. So if there were no solutions as zeros of the numerator, what are my x-intercepts? There are none. So I'll say there's no x-intercepts. Okay. I'm going to find g of 0. Well, if I plug a 0 in for x, I get 6 over 3. That's my y-intercept. And finally, the new part. Oh, wait. There we go. The new part says I look at the degrees to determine my horizontal asymptotes. So what's the degree of the numerator? 0, because it's constant. Degree of denominator. So n is less than m. Y equals 0. So I'll write horizontal asymptote, y equals 0, and this is one of the rational functions that you saw all the way back in Algebra 1. It's your normal 1 over x that was translated 3 to the left and has a vertical stretch by factor of 6. Meaning I can now take 6 divided by number and use that to create more of these points. For example, see how from this crosshairs, this is 3 to the right? 6 divided by 3 is 2. So what's 6 divided by 2? What's 6 divided by 1? 23, 4, 5, 6. 6 divided by a half? 12. Take it the other direction. 6 divided by 6? 1. 6 divided by 12? A half. So, and you connect the dots. What about the other side? What's 6 divided by -1? Okay, so it's the same thing, it's just mirrored down. 6 divided by -2 is -3, 6 divided by -3 is -2, 6 divided by -6 is -1. Okay, so vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept, find some more points. Oh, it does say to state the domain, not -3, right? Negative infinity to -3, can't touch this band, no. I always forget that part when I do these. Okay, see it again. Now, I know that the book wants you to just find the asymptote by accident on this. We're going to do it for real and just keep getting more practice with it. So, step 1, zeros of denominator. So, I'll say there's a vertical asymptote at x is 3. Zeros of numerator gets me x-intercepts. I got 5 and 2.
-2 and -5.
5 and 2. Because I would have x minus 5, x minus 2 equal to 0. So I'll have x-intercepts at 5 and 2. So I'll mark right here and right here. Okay. Also find k of 0, which means those are all going to go away. -10 thirds. So 3 thirds, 6 thirds, 9 thirds, 10 thirds. My horizontal asymptote. Degree of numerator. Degree of denominator. N is greater than m. What do I do? Divide and ignore the remainder. Now, I can do long division, or because I'm dividing by a linear factor, I can do synthetic. Okay, so whether I say, get out of here. So whether I do x squared minus 7x plus 10, x minus 3, say x squared minus 3x, change my signs, -4x, plus 10 minus 4, -4x plus 12, change signs, -2. I get remainder. Or I say, 1, -7, 10 with synthetic. I can do this because it's a linear factor. Isn't it the same thing? Okay. So divide and ignore the remainder means there's my oblique asymptote. So I'll just go mark that line. -4 and I'm making the line. X minus 4?
Okay, well, let's back up. Yeah, what even is an oblique asymptote?
It's a not horizontal and not vertical. It's at an angle, oblique.
How do you find the slope?
But because dividing, and there's a 1 right there.
Oh, never mind. I'm following now.
Y equals mx plus b.
I understand.
All the way back to algebra, half.
Okay, where did the 3 come from again? I got very lost there.
Rational function is dividing.
Okay.
I divided the quadratic by the linear. Quadratic by the linear. The 0 of that factor is 3.
Okay. So you just divided the top by the bottom.
Because that's the definition of a rational function.
I understand.
All right. And welcome back. Now that we're here, you see where the dots are? Can you see where the graph is going to hug right up on those asymptotes? Okay. I'm all right with you just kind of winging it there because I can see where the curvature is. But you know that you can also kind of treat these as symmetric. Where if this is up 1, right 2, I can also go down 1, left 2 from this intersection. If this is left 1, up 1, then I can also go right 1, down 1. If from this intersection I can go 1, 2, 3 to the left and down 2 1/3, then I can also go right 1, 2, 3, up 2 1/3. Like if you play chess at all, those L shapes that the knight likes, okay, it's the same thing. From that intersection of asymptotes, you can make those L's in opposite, symmetric to origin or symmetric to this point. You can make those little L shapes to make more points. And as I start filling them out, I will do one of those numbers.
I am so lost right now. How did you get the points? Like I'm genuinely that like.
From the intersection of my asymptotes, I already knew my x-intercepts. This x-intercept was right 2 and up 1. The mirror of that is left 2 and down 1.
Correct.
So I make its mirrored point. This point right here, my y-intercept that I found from the equation, from this intersection is left 3, down 2 1/3. So I should be able to go right 3, up 2 1/3 to get its mirrored point. You're going to get a bunch of these.
How do we find other points?
Y'all ever seen like the like different mathematical dances? And it's like the line, the parabola. Okay. I used to have that shirt and then I burnt a hole in it, so oops.
So how do you find other points besides the points that we have?
X-intercepts y-intercepts, mirror those points wherever you can. That's all I can find right now.
Okay.
If I need to find any more points than that, I literally just need to graph by table. But I was able to find 6 points on here using my 2x-intercepts and my y-intercept and then mirroring them. I made 6 points. I can see the curvature of the graph. I have my asymptotes to follow along. So I'm going to wing it. Okay? I told you to stay on Earth, and now you got Thanos snapped. Good job. Can't follow instructions. Those two, please. You can have as many as there are factors on the denominator. You should see these graphs when you start getting like a quintic over a quartic.
So you can have multiple vertical asymptotes.
Uh-huh.
Ew.
Can you have multiple horizontals?
Uh-huh. But that's like Calc 3. No.
Can there be 2
Are you?
asymptotes?
Yes.
Oh my gosh.
Can there be more than one person your parents don't allow over to your house?
Yes.
There can be more than one hole in the domain. I thought it would have been the other way around.
I'm not allowed to Rudy's house.
Well, his mom was definitely surprised when I said y'all went to Walmart.
My mom?
Yeah.
Oh yeah, she was just like, why would you do that? And I just explained it to her.
My mom was like,
I just told her, I was like, yeah.
I just told her. It wasn't even that bad.
And then
No stop on my account. I hear everything anyway. You should not have 2 y-intercepts. I just heard 2 y-intercepts.
I don't know what.
Okay.
one and two.
So there's divided by
Right? So that's the
2 divided by negative 3, negative 2/3.
Yeah, zeros of that are the
What? Huh? Where are you getting a negative 1 from? It's 0 plus 0 minus 3. If I plug in a 0, 0 plus 0 minus 3. Because T'Challa said, open the shield. Said the only time that you can cross a horizontal or oblique asymptote is when there's a solution to the system between horizontal asymptote and x-intercept.
You said it was the pressed ham?
Yes, this one is pressed ham, yes.
Wait, no, what did I say? 4 plus 8. I'm just asking you.
Hey.
I forgot the domain.
Oh.
We don't need anything else. So that'd
Did you get
Mm.
vertical asymptote?
Can I book the y-intercept since there's two intersect points? Or how many lines are there even gonna be on this?
There's going to be two vertical asymptotes, one horizontal.
Like that. And then where's that point that I would put it over here? Does it end over there?
You should be able to.
There is no horizontal.
Okay, we got a little bit of brain fuzzy here. I'm going to go through the first one. Okay. If I see something that's factorable, I'm going to factor it. Getting vertical asymptotes at x equals -3 and x equals 1. Because those are the zeros of my denominator. So, for my horizontal asymptote, I see x to the 0 over x to the second. N is less than m. I got a horizontal asymptote at y equals 0. My x-intercepts come from zeros of the numerator, but 2 does not equal 0, so there are no x-intercepts. Finally, if I find h of 0, then these become zeros, and I get -2/3. Y-intercept of -2/3. Okay. Now the question was asked, can I mirror this? Because it's left 1 down 2/3 from this intersection. Yes. So right 1 up 2/3. Huh.
Can you mirror it in the other intersection too?
In this particular case, yes. Not always. Meaning, if this was 1 down 2/3, this should be from here 1 down 2/3. Meaning I will make a big ol' U there. And these things love to alternate kitty corner across those intersections. And I can see that right here already, that it's going to skirt along there. So this one will. Now, if I don't know that for sure, you can always just dump the original into your calculator, graph by points. Okay? Having seen that, can you finish off 2B? Same deal, different numbers. Grace, was there a brain fart or were you on the next page already? Oh, okay. Before we get to them, it's not going to happen on 2B, but just to let you know, if there's ever an x-intercept that is also on this horizontal asymptote, that is like open the shield, section A23. It will let the graph through a horizontal asymptote. You can actually go through horizontal and oblique asymptotes if there is a solution between the system of that asymptote's equation and the numerator zeros. There are some cases where you can cross through horizontal or oblique. In our class, we will not cross through vertical. Yes, because right now these are all functions. If you have non-function relations in which you have multiple horizontal asymptotes, then yes.
So that means your y-intercept is at 0. Because it's 0 over
Yes. This is pre-calc. This is the foundation before the calc.
Bless you.
y equals 0.
Look at this.
Because isn't there an x-intercept on the horizontal asymptote? That is the one part of the shield that has been opened.
I'm confused.
So the x-intercept is 0.
So there's
Okay.
so there is an x-intercept.
Yes.
It's
How
0.
does? Oh,
Because x equals 0.
oh, that's true. I
But
thought
it's
I was
just-
like x cannot equal 0 for some reason. That's really dumb.
Okay. It is possible to go through horizontal and oblique asymptotes under the right conditions.
Did you have this one? So can you go left, right, one over? So does that mean to go
Yeah.
Yeah, because so Mr.
Hmm.
It can go through the horizontal asymptote.
It can.
Okay. How do you know who knows that? That's why I
Okay. Vertical asymptotes. X equals -2 and x equals 1. Set the numerator equal to 0 is my x-intercept. Plug in a 0 to get y-intercepts, so 0, 0, 0. I get 0 over -2. So there is also a y-intercept at 0. Should make sense, there's an x-intercept at 0. And then my rules say, because there is a degree 1 on the numerator, degree 2 on the denominator, since n is less than m, then my horizontal asymptote is y equals 0. Okay. So, I said it is entirely possible to go through a horizontal or an oblique asymptote under the right conditions. The right conditions are there is a solution between the system x and y equals 0. There's a solution to that system, and it's at 0, 0. So that is the nexus. That is the alignment of the planets. That is, Mom said, okay, you can go on a road trip to Montana this weekend by yourself. Like, it's just everything aligns perfectly, and the thing that you did not expect to happen, happened. It can occur. So that means I'm going to go through that asymptote. So I need some more points. Okay, this is at the origin. I can't mirror it. It's on the asymptote. I can't mirror it. Now's where you grab a calculator and you find a couple of more points on graph by table. Okay. So I'm going to ask for just a few more points. Whoa. What are you doing all the way over there? There we go. Y is clear. Alpha y equals brings up a fraction. We're going to say x over x squared. What was it? Minus 2x? Plus x minus 2. There we go. Plus x minus 2. Second table. Now I want that back to auto.
Is this graph is going to change already in this back form?
No. Oh. That's still going by point ones. Go by ones. Start at, I don't know, -5. There we go. There's our regular. Okay. So I see at -3, it's -3/4. I'll go make a point. -3, -3/4. At -2, error. Well, yeah, that's a hole in my domain. -1, it's +1/2. At, keep scrolling here. At 2, it's +1/2. And then 3/10, and then. Now you're going to get more experience with these, but just seeing those 3 dots, I know that it's going to curl along the asymptotes, hitting that point. It's going to curl along the asymptotes, hitting that point. And because I see a point over here, and I know that there's a hole in the shield right there, it's going to start up here, go through the shield and down.
No, I have never felt like that.
If we run across it, we'll play with it. That's a good question. Oh, speaking of, remember that upper-lower boundary thing?
Yes.
I put NCTM on blast and still didn't get an answer from anyone. National Council of Teachers of Mathematics. Like, I was tagging people online and saying, why? And what a bunch of pedantic jerks kept saying over and over is that it's a single conditional statement, not a biconditional. I'm like, yeah, I know that, but why? And no one could answer me. There was literally no one in my small realm of influence who could answer the question, why didn't 4 follow the upper boundary test, but 7 did? Well, because you have a -13 over here. Well, yeah, I know that, but why? Why does that change the criteria? And no one could answer. So whoever had that question, like, why did we have to 7 and not 4? Teachers don't know. Like, you know the difference between a conditional versus a biconditional? Maybe not in those words. The difference between an if statement, if then statement versus if and only if. If then, if Hannah kicks me in the shin, it will hurt. If this condition is met, this statement will occur. Because them are some shoes. Like, they're a big old like leather kicking ring on the bottom of them. Okay. Versus an if and only if is biconditional. It's true both directions. If it's a maroon day, you have Spartan time. If you have Spartan time, then it's a maroon day. Okay, biconditional, both ways. The upper and lower boundary theorem states a condition and a result. It does not say that the result necessitates the condition was true. And they kept saying that. I'm like, yeah, I know. Why? You're not understanding the question here. So whoever asked that, you asked a question that stumped math teachers. Good job.
What was the question?
It's the idea like all fingers or all thumbs are fingers, but not all fingers are thumbs. All thumbs are fingers, but not all fingers are thumbs. That's the difference between a conditional versus a biconditional statement. They were unable to answer why does this being a 4 not work when 7 does. Like no one was able to give that reason. So I remember that was a thing and we were supposed to write it down and I was going to look into it. Well, I looked into it and everyone said, huh? So we're going to come back to those two. I want to take care of this one. Maybe. Depends if we need practice with them.
I think we should.
Because those are ones with the oblique. So we're not there yet. We're going to come back to them. All right. Round 1. I see stuff that can be factored. I should factor it. Yeah, they say. I'm going to take out a 3, leaving x squared minus 1. What? We're not yet. We might go back. I don't know. X plus 1, x minus 1. Downstairs. X plus 3, x minus 3. Completely factor it. Can I cancel any factors?
No.
Okay. I heard like one muttered no and then some weird screeching noise. So, all right. Now that I'm here, do the same thing we just did. Zeros of your denominator are vertical asymptotes at x equals -3 and x equals +3. Zeros of my numerator create x-intercepts. So it's going to be at plus or minus 1. So I'm going to put dot at -1, dot at 1. Cool so far? And then the horizontal asymptote depends on the rules. The rules state the degree of the numerator and denominator are the same. So I just look at the leading coefficients. 3 over 1. So I'll have a horizontal asymptote at y equals 3. What else is missing? Y-intercept. I'm going to plug in a 0. So that part is gone, and I get -3 over 9, which is 1/3. So at 1/3, I get this y-intercept. You see how there's 2 x-intercepts and then what almost looks like a maximum to a parabola right in between them? That happens. Specifically, that happens because of this 3, meaning there is a 3 times stretch in between your graph and the asymptotes. So I can also mirror these. Look at what happened. From that intersection, left 2, down 3. So I can also go right 2, up 3. Theoretically. Check that one on your table. And then this one was right 2, down 3. I'll go left 2, up 3. Someone check for me in the calculator. Make sure I'm not just BSing this. Yes?
How do you know whether or not
you can use that. Because for some of them, like the one you did before, you definitely couldn't use that thing where you go over and then down.
Because the point was on the asymptote itself. I want you to double check this on the calculator, look in the table. Is -5.6 a point? Or am I just BSing that? Okay. At -5? All right. Well then, there's 3, 4.5. Okay.
See, how come those don't work?
I would assume it's because this one down here has a U shape to it. Because it's got that U shape to it, I'm guessing that's why it doesn't mirror around that intersection of axes. But we did find 2 other points, right? If I found 2 other points, then I'm able to create the shape of the graph. So you find all your asymptotes, you find all your intercepts, and then find a couple more points to kind of fill out the shape of it. Okay. There's a whiteout. I can't see. I point my car in the direction that the road was going. All right, now stick my foot out the door and just feel for the grass. Okay. Close enough. Don't do that. Don't do that. I grew up in northeast North Dakota, where like the storm that we just had last week, that's like a weekly thing, except it's like 20 below. So.
Like that one in the tree. I was thinking that like what's the story behind that one? That's what I'm wondering.
Yes, America.
America, okay? But specifically, during the winter, the jet stream dips down just like this. And that's where I grew up. So it was not uncommon that Grand Forks County, North Dakota was colder than Fairbanks, Alaska for most of the winter. So. So. Okay, they both got a different flavor. Get them both.
Is that why one of the videos was
Okay.
It was?
One of the videos you had
You missed the one from yesterday, right?
was one of the ones you had was inappropriate content for like a couple hours. I couldn't get it on my school computer.
That is so funny.
That's the day that we talked about. I texted Rudy. I was like, "What happened?"
Oh, yeah, I think I tried to watch that one.
Just wondering if you.
Oh.
No. Just do the problems.
What did this do?
Wait a minute.
I just want to go home. I didn't go to bed till 2 in the morning.
Sounds like a choice.
No, it's doing homework. I didn't get off till 10, and then
That sounds like 2 choices.
Imagine having a job.
I really just didn't have
Hey, at least you have hockey practice. Stop it. I had work full-time now, and then I had American history and English honors.
Yeah, I just put
Because I work all weekend because they have.
Do the problem.
Oh, yeah.
No, you're not. You're complaining about life. You got your whole life to do that.
I'm not making it to 50, guaranteed.
it's sad. Okay, and then you can be that little elf. 1, 2, 3, 4. Yeah, we can be the elf because
Hey, what is this negative?
And then your y, which is like your horizontal axis. Plus a or n equals n, so you just divide. Okay. Is that one? Is that one?
is this where you're supposed to practice? Why is that? Oh, you guys. I just did not use the calculator. I'm too good for the calculator.
Nice.
Okay. I've got the 4 features for both. Vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts. From there, we're going to talk about how to finish off the graphs. But you have to be able to get to this to begin with. Are we doing okay with our asymptotes and intercepts?
I think I want to write this all down on a little card. And then just keep that.
Okay.
Because I feel like that would help.
I'm so sorry.
And then I was on passage. So same degree, so your horizontal aspect
I usually go.
Yeah, that one's good. No, I really didn't.
Man, if only that note card that you were talking about was an entire sheet for the chapter. Oh, hey, look, there's that cheater.
Wow.
I have these for everything from Algebra 1 up. Really good for ACT review. Now, you can't use them, but they're good for review. Oh, speaking of, I just learned last night, is there an ACT this weekend? Who's taking it? Okay. May the force be with you. For the next ACT, we're looking to organize test prep and do that for the rest of the year, every probably 2 months, I think. So, to finish off the graph, see how this one has only one set of vertical horizontal axes? I should be able to use those L shapes to complete more points. If this is right 2, down 4, I should be able to go left 2, up 4. If this is right 8, down 1, I should be able to go left 8, up 1. This is itty bitty, but you should have this like U just snugged in there and curl really tight next to the asymptotes here. Okay. Through 3. Oh yeah, we can do an assignment out of that. I don't know if it's accurate on Plan Book right now, but as soon as it is, I will also send it out on Remind. I will not get to them today because it's a white day.
Did you actually try to tuck it?
No?